Welcome to today's Data Science Meetup. Our today's guest is Dr. Jean Metz. Jean, I had the pleasure to ask you a few questions in the Erium podcast, and we enjoyed it very much. So the thought was quite obvious to say, hey, let's have a e-meetup together to have a deep dive on the clean code journey in data science. I'm very looking forward to your talk, and without saying anything much more, the stage is yours. Please go ahead.
Thank you, Theo. Thank you once again for having me. It was really nice to have that participation on the podcast, and it's even better now to have this opportunity to discuss about a topic that is really dear to my heart with the community. It's not only something that is talked about quite frequently in the last years, but it's also a topic that generates certain heat in discussion sometimes. Being passionate or sometimes unfriendly conversations about this. And I've been working with or trying to bring this kind of topics to my day-to-day work in the last years when interfacing with engineering teams and data scientists. So I hope I can spice up the discussion between us today, and I really hope that you guys, join the conversation, and then we can, discuss some topics that might be interesting for us all. But before going further, I would like to actually know what the audience is like. What's your background? Like, is everybody here is a data scientist, or maybe there is a software engineer? You can maybe put your job description in the chat, and I get an overview, because yeah, I have to be careful with the words that I use then after that. Otherwise, I will not be able to be in the in-person meetup without any physical risks. Okay, software engineering, full stack, great. Cool. So it looks like there is more data scientists as I was expecting, but there is also software engineering. It's always good to have a software engineer in the audience when talking about this. Because actually, I would like to start with a more controversial part. It's like, have you ever heard this phrase? Because this is something that in the past disturbed me a lot. Coming directly straight from the academia, working for many years with research and machine learning, and diving straight into an engineering team. When I first came to Europe, I heard this a lot. Data scientists don't know how to code. And that disturbed me. And this is kind of commonplace in many companies, at least what I saw in the last years. And this kind of creates, this battle between two giant groups, the engineering and the data science. And in my point of view, this is useless. This is completely unnecessary, and more important, is unproductive. This does not bring any value to the company. If we, as different groups, or we have different profiles, let's say a data scientist, an engineer, data engineer, whatever is the job role, or more technical, more close to engineering programming than statisticians and mathematicians. If we start arguing about things that, interfere with our day-to-day job, we are wasting energy and resource instead of solving the problems that we are theoretically hired for. So the question is, like, do data scientists actually need to code to do their work? Is it important, or is there any job role or any place where you can work without actually coding? Right. So if you do a quick research, you'll notice that there's a lot of articles around this job don't need any code, or data scientists just need to know how to use pandas and NumPy, and that's all, and so on. But the truth is, it doesn't really matter how many POCs or proof of concepts we do. It does not count if it does not get into production. So for your customers, we are not actually adding value to our customer or to our company if we don't transform this code somehow and put it in production. So we, as a data scientist, we also have to open a little bit our mind, in the sense that we, in the end of the day, we code, we produce software, right? So just bear in mind with me, it's going to be not that painful in the end. The thing is, this journey of getting your POC, proof of concept, or the code that we do in research mode and transforming into a production level, as usually engineers say, it does not need to be that difficult. You know, there are certain things that we can use and tools, simple tools that we can use to automate this process and help us out to identify certain elements to make our life easy and then move faster. All right. So to understand this a little bit better, let's just imagine that data science would be magic. We all know that it's not, but you know, let's just think as a magic thing. And I'm going to walk you through a story, a kind of a small story on a data scientist who developed a proof of concept of a super nice magic lantern. And this magic lantern, you know, every now and then it magically recharges, you can continue using and so on. So I'm gonna skip the details, but the idea is that this magic lantern or this machine learning algorithm, it was approved by product owners, by the team or every stakeholder there. And it was deemed good to go to production in terms of the value that it delivers. So there is the expectation that this algorithm would deliver a lot of value to the platform or to the company, right? So now we start a journey and transforming this code, and it was a proof of concept, into something that can be deployed in production, that is scalable, that is maintainable, that has a long shelf life, for example, right? So the journey begins, but with the target of being able to get to that gate, the production code gate. So we keep in mind that idea of data scientists don't know how to code for now, which is not true in my opinion, but just keep that in mind. So we need to prove our value. We need to prove that our code is worth of passing that gate of production, right? And for that, we are going to have help of a group of animals, the animals of the forest. We are going to walk on this, you know, black darkness and the night over the forest, and we're going to have some help from them, which is basically a metaphor for your teammates in this case. And the idea is that we need to pass on a very critical guy. The great wizard continues integrate, right? This is the person that we need to convince that our code is worth of putting in production. Right, so the journey begins and we have to do some tasks before. If you look at this continuous integrate, he has a pet who is really, really angry. You know, he doesn't like bad code. And he is never allow our code to go into production if we don't, you know, do some things to prepare to make sure that it has a certain minimum standard. So we are going to first tackle the project structure and then some kind of automated code quality or checks that we can do. Further, we need to make sure that our code runs at least, you know, since we're just coming from a POC and going to production, we need to make sure that at least happy flow or some tests are there. And for sure, we actually want to get this help from our teammates and review our code, review our solution. And once they say that it's good, then we can, you know, we are more confident to show the solution to continuous integrate. And then, you know, let's see what he tells us about it. So let's start with project structure. Being data scientist in most of the companies that I've worked for, or even when discussing with my close friends that are also data scientists, most of the time what they do is they work in Jupyter, right? They write a POC and they quickly validate ideas. They can use the super tool to actually also sell the idea and present visually the results, which is nice. Who doesn't actually use Jupyter for quick investigations, right? But the idea is that if we want to go to production, the code that runs in production, if you ignore Netflix, is not a Jupyter notebook, right? Netflix proposed in a few years a pipeline that gets Jupyter notebooks, do a lot of, you know, magic stuff there, and deploys Jupyter notebooks in production, which is great. But not every company is Netflix and has the money to invest on that pipeline that they proposed. So in general, what we do, we transform this Jupyter notebook into a Python module, and we go from that one. Another important aspect to consider is if you are working on a company that has many teams working in different domains, it's super nice when you have a standard project structure, where people understand. And you get a code base the first day you join a team, you immediately recognize the structure. You know where to look for if you're getting familiar with the code. This speeds up also your onboarding the team. And obviously, using Python modules will allow us to perform the next tasks that we're going to tell about. So there are certain tools that you can use for helping you out in this standard structure of the using kind of a template for your projects. Then everybody can create new projects in the same way. And having this starting point where it's very familiar to you. And one of these tools is cookie cutters. And I think that Theo did the presentation about cookie cutter in the past, right, Theo? In
Last week, exactly. Yeah.
Yes, I knew it. So once we have that, we have this decent structure, or this standard structure, and everybody understands that. But this still, if you just copy and paste code from Jupyter Notebook into a Python module, it's not going to sort out. And I also want to ask you guys to pay attention on a common behavior I've seen in some companies in the past years, where you start on a Jupyter Notebook and then you do a quick change and they say, "Oops, this is my final version," and then I'm not really happy. I'm going to create another one. You copy and paste and do a final, and so on and so forth. This is not good. You have Git, you have other stuff to control versioning for you, right? And also the naming is really, not really ideal. So having proper names to that module, which represents the concept that this module implements, is really important. Another thing, don't need to pay attention to details or try to read the line. Just the orange boxes or orange arrows are what I want to call attention here. In general, the Jupyter notebooks, when you're playing around, just trying to investigate, you have a lot of unrelated code, unrelated to the task that you are trying to solve. For example, you don't remember how to call an API to generate a random number. So you put some code there to try out and forget to delete. There's some cells which you know that you are not going to use it anymore, but you are afraid of delete. So you just comment it out, right? So this is dead code. It's never going to be used anymore, but still it's there. There are duplicated codes, so cells that are very, very similar. The only difference is a specific value of one variable or two, things like this. So this is definitely breaking one of the principles of software engineering, which is do not repeat yourself, and so on. And also there are things in the wrong place. For example, cells that are out of order, or imports that are not in the top, which, this is a minor one, but also some people don't really like it. And this dependency of order, it makes a nightmare for the life of anyone who will get this notebook and try to execute it. You just don't know where to start with. So before we hand over this POC to engineer or help the engineers to productionize this, let's make sure that we organize this thing in a way that it's easier to proceed in a faster mode. One thing is basically delete everything that you don't need. There is something called YAGNI, is an acronym for you are not gonna need it, or something like this. And this is one of the things that I see most frequently, people keeping code that's unnecessary because they believe that one day we'll use it, even functionalities that one day will be necessary, but it's seldom you need this thing. So all unrelated code should be removed. Duplicated code should be maybe externalized into a function with parameters that you can reuse. And that means you also be able to modularize this code and write proper tests to that functionality, right? Organize the code into parts that, everyone can understand where it starts, and the flow of execution will help on this transition to the production, in the sense that engineers will be able to, focus on the scalability problem instead of trying to understand where do I start, right? This kind of things is actually very important to make sure that this process is faster. Something that does not depend on the order of the cells. So again, Jupyter Notebook is amazing, but if you know where to start, otherwise it's a bit difficult. And the fact that you can extract functionality from cells and create functions also allows you to look at this bit of code and try to make it very small and simple. Simple is much better than anything complex, because most of the time we spend is on reading code. If you cannot read code, then you cannot transform it into something that's more performant, for example. So also pay attention that, if we apply those things, continuous integrate will be already a little bit happier. So, the flames on the dragon is smaller, the face is not so red, and so on. So what to do with this? There are some tools you can use for that. Also, for example, one little Python package which is called voucher. If you execute this code, this tool in your code base, it will print out to you information with a certain level of confidence of what code is that code. That means you can delete it. Or you can use other tools like SonarLint and SonarTube to, just get an idea of, oh, this is code repetition, remove it, And this way you start to improve your code base as you go. So passing by this one, we go to the next stage. So we have a project structure, it's a Python module, and it's, one task we've done. So next stage is, how do I use some kind of automated code check, which will tell me if the code is good, first of all, and then if it's not, please tell me what is not good, what is wrong, how can I sort this out? So we are gonna make use of two magics here. It's not abracadabra, it's I sort and black. So those two very little, tools that we can use during development or during CI/CD pipeline to make sure that your code base is it's compliant to certain standards. The idea of iSort, once again, I'm not going to dive into details. We can, of course, on the comments session later on, but I don't want to really dive into this one because we need more, if it's hands-on, we need more time to do that. But iSort effectively what it does, it just sorts the imports into logical blocks, which makes it very easy to maintain and also avoid certain, sometimes merge conflicts because you change the order, because I executed a command on my IDE, for example, I'm using PyCharm, and then it ordered the imports in the PyCharm way. But if you are using VI or VS Code or Jupyter and it ordered, this in a different way, then we get conflicts for stupid things. There is absolutely no change in the logic, but just change on the import order of this, and you have a conflict. So that's not good. Using iSort is a very simple, it's standard in terms of, the Python community is a Pythonic way of doing this thing. So it's a good one. Effectively just run. You can check first if the order is wrong, and or you can apply the changes. So effectively what we will do is creating, I'm not sure that you can see the mouse, but you see there are spaces between blocks here, but the idea is that you have certain logical blocks of what is external libraries, your code that you wrote that you're importing in, and so on and so forth, or standard libraries from the Python language. And the other one is black. Black is, as they put in their web page, is an uncompromising code formatter. It means effectively that it's not configurable, and I love it because of this. In the past, I worked in a Java team, and actually in a company where everything was Java, and everybody was complaining about the way that the code was formatted. Every developer has its own preferences for that. So we constantly had code conflicts or discussions or wasting energy because, I want to hit an enter in this character and the other one wants to have a longer line. And because it was possible to format, every team had its own standard, which is very difficult when you move across different teams in the company. So if you are using black, you can't configure much. Right? It's going to be all the same across the company, which helps. Effectively, what it does is basically change the way that your code is formatted. It does not change any logic, but how the code is presented to you. So for example, a lot of people I know like to write code like the first cell here, no space in between operators. And definitely for me, particularly, this is horrible. I cannot read that. I still didn't learn German. So I know that Germans like to concatenate words, and that makes my life very difficult. One day I will learn it. So if I could, I would apply black to German languages, sorry for that, just to make sure that I have space in between the operators or the words. So this is one simple example of what black would do. But the idea is, you just tell black how many characters you want to have as the length of the line, and it will apply certain rules. And we'll always respect the rules, the PEP8 rules, to make sure that the change that is performed in your code will not break the standard of the Python community. And the last one that I would like to share with you today is the flake 8. Flake 8 is not a magic spell that will actually change the code for you, but this is, from my point of view, the most helpful, especially for us data scientists, in the sense that let's assume that you are a junior data scientist. You are pretty good at NumPy, right? But you don't have software engineering exposure yet. You have not worked in an end-to-end team or really the experience to work with software engineers. So you most likely commit some flaws in terms of design and how to write code. Flake will look in your code for certain issues that are not compliant with the Pythonic way of writing code with PEP8, and then we'll point out to you. And we'll give you some, some information in terms of what's the reason I'm complaining. So here's an example. In this case, it will tell you what's the file that is, it found this issue, what's the line and the column, what's the code for this rule that the code is breaking, and a short description. With this, you can quickly, look for the PEP8 configuration documentation and try and understand why this is a problem. If I tell you that you should not have prints in your code, you'll probably say, nah, this is not correct. Why you don't want to print? How do you want to see information if you don't print it, right? So there is a reason for that. And the idea of using these tools is that they also gives you a hint and you can research and try and understand it. So this also helps you improve your skills in software engineering. This is just one. Flake also allows you to add some kind of plugins, let's say, or extra packages. For example, there is one called Bugbear. And this Bugbear is looking for a lot of known bugs and security issues also on the code. And it will point out every time it says an opportunity for a bug or an issue that is already known. And then you can fix it upfront before actually having this issue in production. For example, log injections, SQL injection, and things like this, which is very important, right? So using this tool will allow you to quickly identify what to transform in your code to make sure that it is more Pythonic, that it respects this PEP8, and also improve and get rid of some of these well-known bugs along the way. So here's one example. You see that the import is on the line 4th and there is logic before it. So it will complain about it and you just need to change it. And this is another one. There is a print there. Don't use print, just use a logger. Because if you need to see this information in production and you have print, you'll lose it. So don't log important information with print. If you are doing an application that runs locally and just is information that the user needs, then it's okay. But if it's something to debug, ignore print forever. Just use loggers. Cool. So the nice thing about those three is that they work in tandem. So it's very easy to configure them to make sure that they work together and do not step on each other's toes. There is a caveat here. So black and isort, as you can see on this block below here, this dark block below, they are much easier to configure. You just need to configure black with certain, what's the size of the line you want to use and what's the Python version that you want to target in terms of style, right? And then for our sort to just say, hey, I want to use the profile black. So this makes they work very easily together. For Flake, there is a caveat. Two of those codes, which I don't remember by heart, needs to be here. Otherwise, everything that black, not everything, but a few things that black transforms your code, Flake will complain. But this is very clear stated on the documentation too. So you only need to have those lines to make sure that everything will work on your code base. So it's not that difficult, even if you have not worked before with this kind of tools. Once you have this dependency installed on your Python environment and have this configuration, if you execute the command properly, it will transform or at least tell you what problems you have in your code. Go. So there are other alternatives. Instead of Flake, you can use Pylint, or even if your company affords, you can pay for SonarQube server, which will analyze the code. It's, there's a super nice dashboard showing you numbers, which I normally call this SonarQube my wall of shame, in the sense that SonarQube will look to the code and will point out every single problem I put in the code. So that means if I have this wall of shame public in a company, I will take care of that as fast as possible. So, my reputation is on the line. So I need to make sure that I get rid of all the security issues, all the bugs, and make sure that is standard across the company. All right, so now we have our code in a standard way, written in Pythonic style. Everybody knows what to look for is use it to the formatting, to the structure. So what about the functionality? Does my code work? I'm not sure yet. So let's see it. How to do that? If I present my code now, a merge request to the continuous integration wizard, is going to prove that this thing actually works. So how we do this, one simple way is write some tests and make sure that there's a spell that you are proposing is reliable and is going to work when put in production. Right. Idea is you add a tool that allows you to execute tests, for example, PyTest. Then you write some unit tests and functional tests. Obviously, you will tell me, oh, but data scientists, we don't write tests, or we don't have time to write such a ton of tests, right? Let's hold that thought for a second. Then you execute the test and check the coverage. How much of my code is actually covered or tested by this unit test that I wrote? Sometimes, 20%, 30%, 70%. It really depends on the conversation you have with your team. The important thing here, my point of view, is we cannot look for 100% test coverage. That's usually not realistic, but because engineers will use tests as documentation when you are handing over your research work, your POC to actually productionize, make sure that you write the test at least to the happy flows, because they will look at that test that you wrote to understand the behavior of your code. Right. So once they understand this, they may increase the amount of tests. So you need to have certain number of tests that, try out certain border scenarios that make sure that in your test you have some input data as examples. So they understand what's the structure of this data the code is expecting to receive and then execute. And this gives you also more confidence whenever you have to change something, to make sure that you didn't break the code once it's in production. Like you get the code, there is a bug in production, then you get the bug, executes the test locally and say everything is fine, everything is running. You start working on it, you change, you find a way to fix the bug, right? So then you make your fix, execute the code again, make sure that it didn't broke, meaning you fix one bug, don't add another one, right? So, and obviously add the test that cover that bug, you just fix it too. So it's really important to have tests. And most of the companies, they are not going to allow you to merge code into master or the main branch and deploy it in production if you don't have tests, right? So this is just kind of make sure you have this good practice. So there are alternatives for PyTest. You don't actually need to use PyTest. You can use just a standard unit test that comes out of the box with Python distribution language. And there is another one called Nose2. I'm not really familiar with that. Just look at for alternatives to put it here. But then there is this fourth element I put there on the line is hypothesis. If you want to have some help to make sure that your code, your tests are not broken, use a hypothesis. It's going to generate input data to your tests and try to break your code, which helps you uncover bugs that you have not noticed. So this is yet another tool which is interesting to get in your toolbox. Cool. What you do once you have the test? You effectively run the test, right? Oops. Not every time that you run your test, it's gonna pass, right? Sometimes you're gonna have failures in the test, which could be just flaky tests, as the engineers usually call some tests that break randomly, or could be that data dependencies, something that is wrong there. So make sure that you always run the test. Once the test is actually fixed, then you have this 100%, all the tests passed, it's green is good, right? Except for the dragon. But then you can just git add, git commit and push, all right? Meaning the code is good, that it's in the correct standard that we expect. We have unit tests or functional tests, whatever kind of tests that you have. You can just push your changes and then go home, right? No, we still have something else. Before going to production, we need to go to the next step. So you need a code review, meaning that maybe you applied everything so far. Your code is pristine, PEP 8 compliant. What about the design? What about the conceptual aspects of this code? These tools that I just presented, they do not evaluate these kind of things. So you cannot rely on them to tell you that, for example, a parameter for a decision tree is a wrong value. So it expects that a float point in terms of code, right? But instead of putting 1.3, you put, a million there. So this is not something that you'll be picked up by these tools. Maybe there's something else. So we go to the next step with the code review. Just look at that. For now, we are kind of appeasing those gatekeepers. So let's see if we can go to the next step. What is the code review? Once you push the code to a Git repository, to the central or origin and the lingo of Git, you'll probably open a merge request. Sometimes, depending on the tool you are, they also use the pull request terminology. It's effectively say, hey, animals of the forest, please have a look on my solution and tell me if something is wrong or if you agree with those changes with the new functionality. And these guys, which is effectively your team mostly, they will look for, or theoretically, they should be looking for conceptual details there, not really looking for, you forgot this space here. Why did you hit enter this line in this spot? So this is the boring stuff. We should automate them as we are doing so far. So they have the opportunity to actually dive into the logic of the code and bring up some useful comments. Like, for example, the Fox here, she found a bug in the code. And that's where you probably missed it because you were so, involved with the solution and something. And it's always good and helpful to have someone to double check the solution you proposed. With this, the Fox will put a comment there, will tag you, or you'll get a notification, and the discussion can start. Someone else in the team can also join the discussion or even propose a change. There are tools, for example, GitLab, if your company uses GitLab, or if GitHub, where you can propose a snippet of code to apply automatically. You just click a button there. You don't even need to get the code again. And this also helps in the sense that the team starts to understand better the code base and the domain knowledge. So once everything is good, everybody's okay, this looks good, it's approved, then we can finally submit our code to the gatekeeper, right? So we're going to go there and talk to gatekeeper and say, hey, here's the code, just put in production. He would just say, not so far, or not so fast, wait a bit. You told me that you have linted your code, you have fixed all the PEP 8 things or flake 8 compliance, whatever tool you're using to do that, and that you're written test. Let me just double check if you actually did it. So everything that we've done locally, it's going to be run again on the CI/CD pipeline. And then once, format, latent testing, it depends on how you call those stages, but those tasks executed once again on the CI/CD pipeline. If them are all green, cool. Then we can go to the next stage, meaning we can finally pass on this, meaning that the gatekeeper is happy. So then it will allow us to finally go the next step and merge it, the code, merge our solution to master branch, and then it's ready for deploy. Just go there and, whoever has the guts, press the button to get into deploy, to get into in production and make it available for the users, right? So a quick review. This is a very simple journey, applying very simple tools that are kind of business as usual for software developers, but sometimes neglected by data scientist teams or pure data scientist teams. So define a proper structure, some conventions, write code according to the standards for that particular tech stack, write tests, get code review, peer review, the 4I principle, get information from your peers, make sure that this is automatically checked on the GitLab CI, and then just be happy. So thank you for attention, guys. I just want to shout out here for some people who helped me with this storytelling particularly, and with the images. I am terrible at drawing, so all the credits to Pamela with the drawings, and thank you for Pamela, Bettina, and Peter for the story behind this. And also I would like to just leave this slide here for, kind of food for thought. We can talk about this in another opportunity if you want. Thank you so much, and let's have a chat.
All right, thanks a lot. I think this raised the bar with regards to storytelling on a whole new level for all the upcoming e-meetups. Sure, thanks a lot. I've got a list of questions and comments, but yeah, first of all, let's open the stage for everyone in the audience too to raise questions. Please go ahead if you have comments, remarks.
Do you want me to stop sharing so we can see each other?
No. Please keep the slides up, because like for my questions, they will be helpful. Cool. Anyone to share experiences?
Everybody's ashamed.
Because okay. Yeah, I'm not ashamed anymore for ages. First thing, when you mentioned, okay, data scientists don't know how to code. I was about to raise the question, but then I just told myself, okay, Theo, please be quiet for a second. What does code actually mean? Because if you're able to code or not, it's like you have to define what you mean by code. And it became clear to me that with code, you mean like, yes, software development, but it's not like software engineering in every extent. So you with Flake 8 or Black or whatever, you don't, from like yesterday to today, you don't become a software architect, yeah, or like a cloud architect, a solution architect. This is like conceptually on a completely different level, but this is not what you meant. By coding, you really meant creating code that is usable as a part of a bigger picture, if you understood you correctly, right?
Absolutely right. One thing, that's the point I put that question, because this is always something that brings to the conversation, right? As I said, I was really annoyed in the past when my peers, engineers, was always saying, hey, but data scientists don't know how to code, in the sense that actually the design choice is the code is unreadable, is unmaintainable. There is no standard on, there is a behavior that we, especially people that are closer to research, we read the paper and there is an equation and we use exactly the same letters to write the code, right? So there's a big equation with x and y's and z's and theta and whatever, and we effectively copy and paste the thing from LaTeX or from the paper and transform that into Python codes or R code or whatever. And this is definitely unreadable and unmaintainable. So from an engineering perspective, especially if the engineering team that are inheriting this code has absolutely no exposure to that. And of course, over time, they start learning it. But coding is much more than applying those basic things. As I said, it's just really small steps of being slightly closer to production. I didn't mention anything about scalability, for example, or really didn't have the time to break down a notebook to show how I would modularize it to make sure that it's maintainable. Right? I didn't mention anything about documentation. Right? So it's not even scratch the surface, but it's more call attention to the fact that there are certain behaviors that we have in academia, and we bring this thing with us in our, it's our baggage in the end, right? So we bring it from the university, PhD, master's, wherever you did, and we keep this behavior that it kind of hurts the process of transforming our solution into production level code. And if an engineer that is like really specialized colleague that will be able to get your code and make sure that it can process millions of records per second, if he cannot understand your code, he will not be able to do that. So your code might be, or our code, not your, but ours, right, might be the best solution possible for that. But it has to be understood. So documentation, communication, make sure that the code is readable and then maintainable. It's really important. So not only applying those simple standard things, but then go one step further later on in the process and try and understand how to connect this, how this code solution is going to integrate, so you can anticipate things that the engineer will ask you anyway. One common behavior I see is using loops, for example, right? Instead of vectorizing applications. Think like me, just bear with me. When you are doing your scratch on paper, do you write loops or you write algebra to, use all those matrix with NumPy and all those things? I doubt that you write loops. You are writing mathematical operations. You are writing, when you're thinking about it, you are thinking on vectorized operations. But then a lot of the data scientists that I know, when they go to Python, they don't write read-to-write operations, they write loops. Right, so a small step to think about it. This is a language, or in Python at least, and I think that R also supports this. I'm almost sure about that. Shame that I haven't used R for so long. You have native support for vectorized operations, which means that if you write small functions, a small code that do one thing and one thing only, which is clear, you give a proper name, and it does a vectorized operation, probably the engineering team that's responsible to put this in production will never touch this function anymore, because it will not have a problem with scalability. It's going to be fast. But if you write a loop, then they will try to understand that. If the name of the variable are x and theta, that's already a delay on the process.
Yeah. Another comment that I wanted to make is one of your last slides, the code review. Maybe you can jump back on the slides where you just mentioned that one can use the code comments on
Yes.
GitLab. Exactly that stage. Like, I'd like to second that one, because like we went through the journey, right? Writing PEP 8 compliant code. I annoyed everyone to write PEP 8 compliant code. And then we started using static code analysis like SonarQube. So we're actually using SonarQube too, and did everything. We wrote unit tests. And when entering the world of web development, actually, we realized that it becomes even more important to have those review sessions, not only on like a code level, as you explained, right? The code is like well formatted, okay, but does it make sense semantically too? This is what you mentioned, if I understood you correctly. Yeah, does it make sense? Not only is it like technically correct, and we had to add another layer in terms of, does it make sense in an application level? Because if you create like a web application or something bigger, it may be the case that the feature for itself, or like a functionality, or like a piece of functionality, it makes sense by itself, but it doesn't make sense anymore in the bigger picture. So what we set up was like big bug hunt and feature review sessions, where we collaboratively try to go through the user story again. To really experience the user story and see what is the user experience. Does it make sense, or is there like a gap or a break, a logical break in there?
I think this is quite interesting way of, you know, also bringing everybody up to speed to with what are we doing as a team. Right?
Exactly.
Another pattern I've seen is like some teams, maybe less mature in terms of engineering, they receive a merge request and they look to see if they're very, very obvious errors and click on approve instead of, you know, trying out. So it's also very good to have a quick look on how to do a proper code review, and also if you are the proponent, how to do a proper merge request, open a merge request. You know, really using a kind of a template with your team on how to explain why you're doing this, what this thing is solving. So I already give a context to whoever is picking up to review, and then whoever is reviewing should clone the code. And run locally. Make sure that you know, understand what is this thing, because sometimes it's very difficult using those tools. You know, it shows you what are the changes, but still it's very difficult to grasp, especially if you're involved in many repositories. For example, I have at least 20 or 30 repositories of code in my laptop currently. It's very difficult. So if I don't clone it, don't try to run and check the changes, it's difficult to keep the domain, you know. So these sessions you said is nice. Another aspect that I like code review, especially when it's new team or a new joiner, is to do paired review. So like, for example, if I'm a proponent, and let's use Sandra as an example, just because she's from Nuremberg. And if I'm a proponent of a code review and she is joining the team, I would invite her to do a round through. What I say is, I'm gonna spend 15 minutes explaining to her what's the solution and why, and then I'm gonna give her the time to do a proper code review. So it also brings her up to speed in terms of the knowledge, and in case she is not that experienced with the code or even with the standards that we are using, she has the opportunity to make questions and get even more information and upskill also in this sense.
Yeah, I think this makes perfect sense. So thanks, first of all, for this brilliant presentation. Yeah, I think I have to admit some of these mistakes have been made by myself at some point as well. So I think deep down it comes to habits, right? And not sticking with bad habits and always challenging oneself to produce better code instead of sticking to that comfy area that we have created. That's one thing I think that we can overcome. But how can I? What would you recommend to persuade my team to use the same things too? Because as you've said, it's annoying. It will create more effort, which in the end pays out. But how can I convince others?
Yep. I've joined in last January. I joined a team where they didn't have they were not applying any of those things. It was really coming from a POC, a new team, and I started working with this team of engineers and data scientists, and I brought up these ideas, right? So I started discussing with them. So the first 2 weeks were really difficult. They have never used that. They have never written unit tests and so on. So the engineers in the team that has a little bit more of experience, we have to support quite a lot. But actually, the thing is, it doesn't matter how much you read or you watch videos and all those things. It's if you don't try yourself, you don't pick up one of those aspects and try it out and try and understand and do yourself, you will not learn fast enough. So learn by doing, and also relying on your team to get up to speed, to understand the process is really important, right? So you'll probably make mistakes. Everybody does, right? But once you start to get into the flow, and you will, in maybe 2 or 3 weeks, understand how the thing, and it becomes natural. That was the time it took for 2 of the data scientists in my team to write message to me. Oh, thank you. Now I can test the code. I can write unit tests. So effectively 2 weeks. It was 2 weeks of nightmare, headaches and discussions, because as I said, it's change, and changing behavior. We are very resistant to that. But once you get into the flow, it makes it easy. And one aspect is maybe you can choose one of this. So let's see how isort works. Is it that difficult? No, it's very simple, but you have to remember to use if you are not automating. And some people don't like automation. Even engineering teams already complained about this, of letting isort and black to change the code. They would rather keep only, hey, shout out, tell me there's something wrong there, and I do the change manually, right? I don't know. I like automation. I don't like do those things. I don't like waste time. So if isort will tell me that the code has a problem, and then I will change it anyway, why not just do it for me already? But if you start, small steps or baby steps, let's say, choose one aspect, experiment a little bit, and as you see that you need like 5 minutes to do the isort thing, and then you go for the next. You'll probably need to tweak a little bit some stuff for the flake in some projects, because flake can be very, very verbose, meaning that it can complain too much. PyLint is even worse. It's very strict. So you end up being very frustrated. So you have to choose a little bit your battles. Like, do not complain. For example, one common, there is a space in the end of the line. If you just give one or more space in the end of the line, Flake will complain. So come on, there's no actual logic there. And some teams don't like it, so they prefer to ignore this particular error, right? Or complaint about PEP8. But if you want to be 100% compliant with PEP8, rest assured that you have a lot of, like 20,000 things first time you run your code, if you have enough code. Yeah.
I see. Thanks. I will have a chat with my teammates tomorrow.
And like from my perspective, sure, I just was confused that you said, okay, some people don't like automation. Okay, now I understand that you meant like automated code manipulation.
Yep.
But okay, it should definitely be part of like the pipeline, that the pipeline fails if the code is not compliant with the rules. And I have to say, so what really paid off, and this is why I just wanted to second this automation thing, automate the pipeline, and from my perspective also automate the build environment or like the dev environment, because what we established in the very early days when starting with developing a web application like Erium, we have a pipeline that for every feature branch creates a production-like environment.
Mm-hmm.
So if we change like the fav icon in the browser tab, we create a feature branch, of course, and for this feature branch, a complete environment will be created that you can test, just as the live production environment. And this is super helpful because of this automation, everyone is able to do a proper test for every change, be it so minor. So if I have like a small modification, I, as the CEO of the company, can do the modification myself and still stick to all the rules the dev team has set up. And this is brilliant because, it's just super efficient and quality always is super high.
And that's interesting because if you have this kind of things, and plus you, as you said, you also have SonarQube, right?
Mm-hmm.
It teaches us a lot. SonarQube, it's a company that lives from this kind of thing, so they know the bugs, the new security issues. So you don't need to. You can rely on it to get a first alert. Oh, you need to upgrade this library because there is a the Java log library fiasco of some days ago. So you'll get an alert there and you can react immediately because it's a critical issue and so on. And one thing that I really like too is to have automation on my local machine, even before making a commit. So I use a lot pre-commit hooks. So if I'm trying to commit something which is not complying with the rules, which is gonna break the pipeline anyway, don't even allow me to do commit. But this is even more, let's say, people complain too much about pre-commit, so a lot of people don't like it. It's kind of some love and some hate. I personally really like, because I'm gonna do when I'm doing commit, I can configure it to run things for me automatically, right? So if I forget to link to format the code properly or to check the quality, to everything, it's gonna execute for me, and it will tell me that I introduced a bug or a security vulnerability before I put a commit. So it breaks the commit, tell me what the problem, I fix it, and then it allows me to do commit. I am very fan of this. I know that's not perfect. A lot of people complain about this too, but it's yet another extra bit of automation that once my commits are through, I'm sure that the pipeline is not going to break.
All right. So it's already 6 p.m. So
true.
Let's close this chapter. Thanks again for this really, really great talk and the storytelling and the useful hints. It was very specific. We have to sit down afterwards to collect all the information. So let's check what we can publish online and put maybe in the comments of the e-meetup. Thanks again. A big applause.
Thank you so much, guys, for having me. I hope to see you in a non-virtual one next in Munich.
Definitely. So we're gonna set something up. All right. Then thanks again for this e-meetup. Check out the data science e-meetup page on meetup.com. It's not yet clear if we're gonna have an e-meetup on the 19th, but we are working on it. So we're gonna keep you posted. Have a nice week.
Have a nice one.
See you next time. Bye-bye.
See you. Bye.